All right, well last week we talked about using the graphing calculator to find intercepts, x-intercepts and y-intercepts. Today we're going to talk about doing it just for lines and analytically, meaning without the calculator. But we can check, we can use the calculator to check our work to make sure we did everything correctly. Okay, so here is a line in general form. And here I have the C on the right side, but it will, or on the left side, but it shows up on the right side as well, as we see right here. So it says find the x and y intercepts for the line. I don't know what that is. Okay, so for an x-intercept, y equals 0. So I come over here and substitute in 0 for y, and I get 3x equals 15. So to solve for 3, or to solve for x, I divide both sides by 3, leaving x equals 15 over 3, which is 5. So I have the x-intercept of 5, 0. Now I need to find the y-intercept. So for y-intercepts, x equals 0. So I have 3 times 0 plus, I think that's 5, y equals 15. So that's 0. Okay, so we divide both sides by 5 to solve for y, and y equals 3. So we have the y-intercept 0, 3. Now, it says to use the intercepts to graph the line. So we have the x-intercept of well, I wish I could remember. Okay, x equals 5, y equals 3. Okay. So there's the y-intercept. So now to graph it, I just connect the dots. Okay, so there's my line. Now it also wants me to write the equation in slope-intercept form. So remember, we have the y-intercept. So slope-intercept form, we need the slope and we need the y-intercept. So we have the y-intercept, it's 3. Now we need the rise over run. So it rises 3 and runs 5, and it's downhill. So that would be negative 3/5. Okay, so I just, now that I have the 2 intercepts, I just use that rise and that run. If it were common factors, I would reduce it. Okay, so I did that. And we said the y-intercept was 3, and the slope was negative 3 over 5. Negative because it's downhill from left to right. So that would be my line in slope-intercept form. Okay, here's another example. So we want to find the x and y intercepts for the line, use the intercepts to graph the line, and then write the equation in slope-intercept form. So first I to find the x-intercept, let y equal 0. So 6x equals 9, divide both sides by 6. And I get x equals, and that reduces, you can use your calculator to get 3/2. So my x-intercept is 3/2. Now repeat for the y-intercept, so let x equal 0. So I get minus 3y equals 9. Divide both sides by negative 3. And I get y equals negative 3. So I have an x-intercept of 3/2 and a y-intercept of negative 3. Okay, so we'll use the intercepts to graph the line. So y equals minus 3, x equals 3/2. All right, so let's get a new one. So y equals minus 3. And x equals 1. Oh, let's see. 1.5. That's what 3/2 is. So I'm going to try to get that. There we go, 3/2. I'm going to graph the line. Okay, now, so I have the y-intercept, it's negative 3. So, and now what I need to do is calculate rise over run. So my rise is 3, and my run is 3/2. So, so what I'm going to do is go back. So my rise is 3, and my run is 3/2. Now, it was uphill, so it's going to be positive. So I'm going to take 3 over 1 times the reciprocal there, 2/3. And I get slope of 2. So my my equation in slope-intercept form would be 2x minus 3. Now let's go back and check our slope and make sure that we really think it's 2. It is. So there's up 2 and over 1, and we go exactly through there. And there's another over 1, up 2. Okay, so now we're going to find the x and y intercepts for a line that's in a different form. So to find the x-intercept, let y equal 0. So I get 0 equals 3x plus 1. I'm going to solve for x. And then I'm going to divide both sides by 3 to get x all by itself. So I get the y-intercept of minus 1/3. Okay. The y-intercept, I let x equal 0. And I get y equals 1, which we probably should have figured out just from looking at it, but it's nice to know that even if you're not paying attention, as long as you remember that for the y-intercept, that x equals 0, and you can evaluate it, then you'll still get the right answer. So we have the x-intercepts and the y-intercept. Okay, find the x and y-intercepts for this line. So we can let y equals 0. All right, so we have a couple of different things we could do. We could take this to the other side, or I could distribute this. So that's what I'm going to do. 4 equals 3/4 x minus 3/4 times 2 over 1. Two goes into 4 2 times. You can use your calculator to get the reduced fraction of 3/2. Okay, I'm going to add that to both sides. Again, I could use my calculator to get 4 plus 3 halves. But I'm going to go ahead and find a common denominator for 4 and 3 halves. So that'd be 2. 8 plus 3 is 11 halves. Equals 3 over 4x. Okay. So I can divide by 3/4. And dividing by 3/4 is the same as multiplying by the reciprocal, 4/3. So 2 goes into 4 2 times. And I've said it before and I'll say it again. You can use your calculators to do these fraction computations. So there's my x-intercept. Okay, now find the y-intercept. You can let x equal 0 and evaluate for, solve for y. I'm going to do something a little different though. Since we have to put the equation in a slope-intercept form anyway, we can just do it this way. So what I do is I distribute. I get 3 halves. And now I add 4 to both sides. Okay. Y equals 3/4 x. And now I'm going to have 8 halves minus 3 halves is 5 halves. So this is the slope-intercept form, and there's my intercept, 5 halves. All right, and so that's what I was going to show you.